Adaboost is a ensemble technique. Majorly, when Adaboost was built, it was a classifier. So, how does a ensemble classifier like Adaboost work? It trains multiple weak learners and combines them sequentially to get one strong learner. That is, let us see how. For an example, if we have some links, email classification task, that is email classification, then based on some features like number of links, number of spam words, my model has to predict whether the email is a spam or ham. So let's say for a initial base model, we create a mode model where each prediction is a spam or ham, and this is the F1 model that corrects the F0 model, right? The mode model. So for the first model, we have this predictions. Spam is predicted as spam, spam is predicted as ham, ham is predicted as spam. So there is one error. Adaboost trains many decision terms max depth of 1 in sequential order. Every term tries to correct the ensemble built so far. Tries to correct ensemble built so far. Okay. So decision stump, only one split is allowed in a decision stump. Let's say we create a decision stump as number of links greater than 3. So the nature of this decision stump is in high bias and low variance. Why? Because there is only one split, so bias would be very high as it would be a underfitting tree. So using the weighted scheme, we assign weightage to each sample. Whether it is correct or incorrect, every sample is weighted equal 1 by 3, 1 by 3, 1 by 3. After building a model, number of links equals to 3. The weights, now based on the predictions that we have made, my weights change. For the correct predictions, I would get a lower weightage, and for the incorrect prediction, I would get a higher weightage. So this is the formula to update the weights, where it uses a exponential function multiplied by some alpha and current prediction and previous prediction, where alpha is nothing, just a measure of error. Error is calculated based on misclassified samples. So we can observe that for the misclassified sample, spam is predicted as ham, we get a higher weightage for the misclassification, and for the correct classifications, the weightage is lower. So my second model, my equation becomes h of x, a0, h0x. So my second model gets this weight and tries to correct the mistakes of the higher weightage. So let's say it finds a split where spam words are greater than 5, we predict as spam or else ham. So using just two decision stumps, I can get all my predictions correct, and of course these are random weights, not calculated using formula. But my final model will have a decision stump, is a collection of decision stumps trained individually using weighted scheme. So my h of x becomes a0 h0x plus a1 h1x, where a0 is the decision, the weight of the decision stump, and a1 is the weight of the decision stump 1. Now this is a simple Adaboost training. So what are the pros and cons of it? Let's say it is very simple to implement, reduces bias by training and weak learners. So the bias generally decreases because using the bias formula of is it reduces the bias, right? It reduces bias by training in weak learners, as it goes from underfitting, as it builds underfitting trees, high bias, and each mistake is corrected by the stum next model. So the final model will have a general rule, and each decision stum get a say in the final, depending upon the error it is making on in the predictions. Based on that, we calculate some weights, the weights. So after calculating the weight for each decision term, we arrive at the final model. So as it uses exponential function, what are the cons of it? It uses exponential function, exponential loss function. So my model is very sensitive to outliers, as the weight will keep on increasing for the outlier samples because of the exponential, and my model will never arrive at a lower loss, or you can say the model will never converge. Another is the boosting. It is boosting models are always sequential in nature. Each weak learner should perform better than random guessing, that is, error should be less than 50%. Right? So it is very sensitive to noisy data as well, and the outliers as well. And when we increase the number of boosting rounds, then it can easily overfit. So this were the some pros and cons of the Adaboost.